So we know that the sun is producing light that is responsible for life here on Earth. Without it, the life on Earth would not be possible. Those photons that are produced in the fusion core, they struggle to make it to the surface, right? On average, they travel for about 1 million years after they've been produced in the core to reach the surface. And then we know that it takes about 8 minutes for them to reach us here on Earth, right? Moving at the speed of light. The neutrinos that are produced during the proton-proton chain, they interact weakly with the interior of the sun, and they basically just shoot through it, unhindered at all, moving at the speed of light through the sun and through us and through the Earth and move on into the space. But in addition to light and neutrinos, the sun also produces so-called solar wind. It is an outflow of charged particles from the sun, which is basically the nuclei of hydrogen. So it's outflow of protons and electrons and some nuclei of helium. So this outflow of charges from the sun is called solar wind. And the particles of the solar wind, when they are passing the Earth, they are moving at a speed of about 400 kilometers per second. And there are about 2 to 3 particles per centimeter cubed. And they are responsible for spectacular polar lights here on Earth and on the other planets, so-called Aurorae. And here I have a photo, 2 photos, one of Aurora that was photographed here from Earth, and the one from space, from the space shuttle. You can see this curtain of light, right? So these things are caused by the solar wind, and I'll explain how. In addition, the solar wind is responsible for the fact that a comet's tail always points away from the sun. So basically what happens is a comet is, when it's far away from the sun, say beyond the orbit of Jupiter, it is just like a mixture of ices, of water, ammonia, other gases, and rocks. And then as it passes the orbit of Jupiter, right, it starts receiving enough solar heating so that the material starts to evaporate. But these solar wind particles, that outflow of charge, actually pushes away those evaporated particles that form the comet's tail. So the comet tail, which is formed from evaporated material being pushed off by the solar wind particles, always points away from the sun. No matter where the comet is, the comet's tail is always pointing away from the sun. Here, 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 here. Okay? So it's the solar wind that is responsible for this fact that the comet's tail is always pointing away from the sun. And this solar wind is responsible for Aurorae on Earth, and one can actually see these Aurorae also on distant planets Jupiter and Saturn, which tells us that the solar wind extends at least that much to the orbit of Jupiter and Saturn. And the second effect is that tail of a comet pointing away from the sun. So what is the mechanism for these charged particles comprising the solar wind causing the aurora on Earth? And let me just try to explain that very briefly. And I mentioned before that the Earth's atmosphere protects us by and large from nasty radiation coming from outer space, from energetic gamma rays, X-rays, and a lot of UV gets blocked by our atmosphere. So it serves as a shield. But we have another very important shield that does not exist, for instance, on Mars, which makes things interesting when it comes to sort of exploring the possibility of humans forming colonies on Mars. The Earth also has magnetic field. And magnetic field lines start at magnetic North Pole and at the magnetic South Pole. So I've drawn two, but there are more, right? So basically, it turns out that magnetic field traps charged particles, because the laws of physics tell us that when charges move in magnetic field, they have to spiral along the magnetic field lines. So the solar wind particle, all it can do, it can spiral along magnetic field lines. So these energetic solar wind particles, they kind of are trapped by the Earth's magnetic field. And the only place where they can actually enter, right, if say the particle, charged particle is moving this way, they can enter the atmosphere near the poles. So this one continues moving like so, right? And it hits the atmosphere near the poles. It cannot hit this part here because the magnetic shield protects the majority of the surface of the Earth. So charged particles can enter the atmosphere only close to the magnetic poles. So when one such particle, energetic particle, hits the air molecule, right, it basically causes the electrons in the molecule to go to the high energy states, and as they de-excite, they emit light in the way we discussed how the atoms and molecules produce light, and it is that light that we see as a northern light. And its color depends essentially on the chemical composition of the atmosphere, which molecules are present there. And it turns out that 80% of our atmosphere is nitrogen, right? And then we have oxygen, neon, some water vapor, CO2, carbon monoxide, so on and so forth, okay? So the color of the lights is determined by the chemical composition of our atmosphere. Which molecules are present there, because that will determine what kind of transitions electron undergo in the molecule in coming from higher to lower energy states. So again, energetic solar wind particle hits the molecule of the air. That energy is transferred to the internal energy of the molecule. The electrons jump into higher energy state, and as they come down, they produce photons, they produce light.